Welcome. Tonight we're going to talk about something beautifully simple. Fractions. There's no rush here. Just you, your breath, and a quiet journey through the world of numbers that don't always come whole. Fractions are gentle, precise, and surprisingly calming. They just want to share. So take a deep breath, find a comfortable place, and let's begin. Chapter 1. What is a fraction? A fraction, at its core, is a part of something whole. Not everything in life comes in clean, neat packages. Sometimes you have half a cookie. Sometimes you share a pizza with friends. Sometimes you drink 3/4 of a glass of water and forget the rest. Fractions are how we measure and describe those moments. They help us understand parts, relationships, and balance. They're the gentle bridge between having nothing and having everything. A fraction has two parts. The top number is called the numerator. The bottom number is the denominator. The numerator tells us how many parts we have. The denominator tells us how many parts make up the whole. It's a relationship, a comparison, a subtle understanding of what is part and what is total. Let's take a common one, 1/2, written as 1/2. If a pie is cut into 2 equal slices and you take one, you have 1/2. That one slice is exactly half of the whole. Fractions like 1/2, 1/3, and 1/4 are familiar. They show up in recipes, in time, in daily speech. We say things like, "I'll be there in half an hour," or "just give me a quarter of that." Even children, before they can do math formally, understand sharing. They understand splitting a candy bar in two and giving half to a friend. It's one of our first experiences with fairness, and fairness often lives in fractions. Fractions also offer something comforting. They are tidy. Even when we're not sure about the whole, fractions give us a sense of proportion, a little clarity in a sometimes overwhelming world. They are the mathematics of sharing, of dividing fairly, of organizing pieces and putting them together again. And this concept of dividing and comparing isn't new. It goes back thousands of years. Ancient Egyptians used unit fractions, where the numerator is always 1. The Greeks and Babylonians too had their own systems. Humanity has always needed a way to talk about parts. So when you say 1/3 or 3/4, you're not just doing math. You're speaking in a language passed down over centuries. It's not nothing. It's part of something. And that's what fractions are. They let us measure, share, and balance our world. Quietly. Chapter 2. Everyday fractions. You already use fractions every day. You might not call them that, but they're there. In coffee cups and cooking, in calendars and clocks. Fractions are stitched into the fabric of daily life. Cutting a pie, measuring a cup of rice, telling time, sharing a blanket, measuring distance, pouring half a glass of juice, listening to a podcast and realizing you're 3/4 through. Each of these involves dividing something into parts. Let's imagine you have an apple. You cut it into 4 slices. That's 4 equal parts. If you eat 1 slice, you've eaten 1/4 of the apple. If you eat 2, that's 1/2. 3, that's 3/4. And when you're done, 4 out of 4, you've eaten 1 whole apple. Or imagine you're baking a cake. The recipe calls for 1.5 cups of flour. You measure a full cup, then a half. You've just used a mixed number. 1.5. 1.5. It's natural. It makes sense. And yet it's all fractions. Even the way we divide an hour into quarters, halves, and thirds of time is a quiet dance of fractions. You say, "I'll meet you at 1/4 past," or "Give me half an hour." There are 24 hours in a day, 60 minutes in an hour, and each one is divided, split, and understood through fractions. When you cut a sandwich diagonally, you create triangles. 2 halves, maybe 4 quarters. You don't think about it, but you're applying fractions visually, with each slice, with each share. Have you ever shared a bag of chips with a friend? You each reach in, casually balancing what feels fair. You may not count every chip, but you know the feeling of half. You sense when someone takes more than their share. Fractions live in that feeling. Fractions are not limited to food or time. They are in music, in rhythms and beats, in art, where canvas and space are proportioned with care. Even in language, we say things like half-hearted or a quarter of the way there. We use fractions to shape meaning, often without even noticing. Fractions are everywhere. Quiet little reminders that not everything must be all or nothing. They let us carve the world into manageable pieces. They help us make sense of time, of space, of food, of feelings. And in doing so, they help us feel more whole. Chapter 3. Types of fractions. Fractions come in different forms, each with its own personality, its own little rhythm. These forms aren't meant to complicate things. They are here to help us describe the world more clearly. The first type is called a proper fraction. This is when the numerator, the top number, is smaller than the denominator, the bottom number. Think of 1/4, 2/5, or 3/8. These are parts of a whole, less than one complete unit. They live in that space between nothing and everything. They are subtle, gentle. They remind us that you can have just a little and still have something meaningful. Now let's look at the opposite, improper fractions. These are when the numerator is larger than or equal to the denominator, like 5/4, 7/3, or 9/8. These are more than one. They tell us that what we have exceeds a whole. Maybe you poured too much coffee in the cup. Maybe you walked more than a mile and then some. Improper fractions aren't mistakes. They're just overflows. And sometimes life overflows. Next, we meet the mixed numbers. These are combinations, a whole number and a proper fraction living side by side, like 1.5, 3 3/4, or 5 1/8. These numbers feel human, a little complete, a little unfinished. They reflect how we live, rarely all or nothing, often somewhere in between. Mixed numbers are the moments where we have enough, plus a little more. Then we have unit fractions. These are fractions where the numerator is always 1, like 1/2, 1/3, 1/4, the smallest pieces. Unit fractions are special because they are the building blocks. Everything else can be made from them. They're like single notes in music or brush strokes in a painting. Each type of fraction plays a role. None is better than the other. They are tools, lenses to see the world differently. They help us describe not just quantity, but nuance. And when you understand the types of fractions, you begin to notice them all around you. In footsteps, in shared moments, in small things that aren't quite whole and don't need to be. Chapter 4. Visualizing fractions. Close your eyes just for a moment and picture a perfect circle. Maybe it's a pie, a clock face, or the sun hanging low in the sky. Now imagine slicing that circle into 4 equal parts. The lines are clean even. You've just made fourths. One of those parts is 1/4. If you take 2, you've got half. 3, that's 3/4. And all 4, that's the whole. Fractions live not just in numbers, but in shapes, in colours, in the real physical world. They are visual, tactile, immediate. Imagine a ruler. Each inch is broken into smaller parts, halves, quarters, eighths. Each tiny mark is a fraction waiting to be noticed. Or picture a chocolate bar, neatly divided into 10 small squares. You snap off 2. That's 2/10. You eat 5. That's half. You give away 1. and now you're left with 4/10, 2/5. These visuals stay with us. They make fractions feel less abstract, more like everyday friends we encounter in the kitchen, at the park, or at a picnic table. Even time is visual. Think of an analog clock. It's divided into 12ths. When the minute hand moves, it marks a fraction of an hour. 15 minutes. That's a quarter past. 30? That's half. We see it. We feel it, even if we never say the numbers aloud. Visualizing fractions gives us access to their meaning. It helps us compare them, seeing that 1/2 is larger than 1/4 because one slice of pie is clearly bigger than the other. It helps us combine them, fitting 2 1/4 slices together to make 1/2. And it reminds us of something simple, that numbers don't have to float in the air. They can rest in your hand, on your plate, in your field of view. When you see fractions, not just calculate them, you begin to feel their presence more deeply as balanced parts of a whole world. Chapter 5. Fractions and Decimals. Fractions aren't just things you see in pies or clocks. Sometimes they wear a different face, one with a little dot, a decimal point. Decimals and fractions are two ways of telling the same story. Different voices, same message. Take 1/2. You know it well. As a fraction, it's 1/2. As a decimal, it's 0.5. 1/4 becomes 0.25. 3/4 becomes 0.75. You've probably seen decimals more often. On calculators, cash registers, receipts, and gas pumps. They show prices, distances, measurements. They feel modern, clean, digital. But behind every decimal, there's a fraction quietly standing in the background. Because every decimal, even a long one, has a fraction inside it. Think of 0.333, a decimal that never ends, repeating forever. That's 1/3, just expressed a different way. Or 0.125, a short and quiet decimal. That's 1/8 in disguise. Decimals are just another lens, another way to see pieces of a whole. They're helpful when we want precision, when we measure ingredients or check interest rates. When we want to compare quickly, 0.6 is more than 0.59, but decimals can also be confusing. Some go on forever, some repeat, some can't be written neatly. That's where fractions still shine. They remind us of structure, of pieces that fit together perfectly. When you switch between decimals and fractions, you're not changing the value, just the viewpoint. It's like looking at the moon from different angles. It's always the same moon, but some nights it's a crescent, other times it's full. It's still there, quietly orbiting. Fractions and decimals work together. They help us see the world more clearly, whether you're slicing a cake or adjusting a telescope. And in those soft transitions between forms, we find something beautiful. Flexibility. Numbers, like people, can take many forms and still mean the same thing. Chapter 6. Fractions and Percentages. Now let's explore another form that fractions take. One you've probably seen all around you, from weather forecasts to supermarket signs. Percentages. The word percent comes from Latin, percentum, meaning by the 100. A percentage is simply a fraction with a denominator of 100. It's a way of expressing something out of a total of 100 equal parts. So when you see 50%, you're seeing 50 out of 100, or 1/2. 25%, that's 1/4. 75%, that's 3/4. It's a clean, familiar format, easy to compare and easy to understand. That's why percentages are used so often in real life. They offer instant clarity. 90% on a test? You know you did well. A 20% chance of rain? Probably just a drizzle. Let's connect this to what we've learned. Take the fraction 3/5. To turn it into a percentage, you divide 3 by 5, getting 0.6, and then multiply by 100. That's 60%. 3/5 is 60%. You can imagine this visually too. Picture a pie chart, a colourful circle divided into slices. If 60 of those slices are shaded, you're looking at 60%. You're looking at 3/5. It's the same idea, dressed in different clothes. Percentages are especially helpful in making decisions. When something is discounted by 30%, it tells you clearly how much you'll save. When a poll says 68% of people agree, it gives weight to opinions. When your battery says 5%, you know it's time to recharge. And just like fractions, percentages can be comforting. They help measure effort, emotion, change. You can be 100% certain or give 110%, at least in spirit. So the next time you see a percentage, remember, you're seeing a fraction in disguise. A quiet, familiar whisper of a part out of a whole. Chapter 7. Comparing fractions. Now let's imagine two slices of cake on different plates. One is labelled 3/8 and the other is labelled 1/2. Without eating them, which one gives you more cake? Comparing fractions is like comparing portions at a dinner table, a quiet judgment of what's larger, what's smaller, and what's just right. At first glance, comparing fractions can be tricky. The numbers vary. The denominators, those bottom numbers, don't always match. But if we find a common language between them, the comparison becomes clearer. That common language is a common denominator. If we take 3/8 and 1/2, we can express 1/2 as 4/8. Suddenly it's easy. 3/8 is less than 4/8. So 3/8 less than 1/2. It's like translating different dialects into the same tongue. Once they speak the same, you can tell who has more. Sometimes you don't even need to calculate. Fractions with the same numerator but different denominators tell their own story. 1/4 versus 1/8. The bigger the denominator, the smaller the slice, because the whole is divided into more parts. Other times, you might feel it intuitively. Think of a glass filled halfway versus one filled to just a third. You see which has more. Comparison is about context. In recipes, it can mean the difference between just enough salt and too much. In construction, it can mean stability or imbalance. In life, it can help you choose wisely. Which route to take, which option gives you more, or which effort needs more time. Fractions don't shout, but when you learn to listen, they quietly reveal which part is greater and why. Chapter 8. Equivalent fractions. Sometimes in life, things look different but mean the same, just like people who dress differently but share the same heart, or books with different covers that tell the same story. Equivalent fractions are numbers that may not look alike, but hold the same value. Take half. It's simple and familiar. Now look at 2/4, or 3/6, or 4/8. At a glance, they seem distinct. But if you divide both the top and bottom of each by the same number, they all reduce to 1/2. That's the heart of equivalency, reducing or expanding a fraction without changing what it truly means. It's like resizing a photo. Whether you view it large or small, the image stays the same. Or like zooming in and out of a map, the landscape doesn't change, just your perspective. To find an equivalent fraction, you multiply or divide the numerator and denominator by the same number. Multiply 1/3 by 2 on top and bottom, you get 2/6. Multiply by 5 and you get 5/15. Why does this matter? Because it helps us compare, calculate, and simplify. In real life, we use equivalents without even noticing. When we say half a pizza or 2/4, we're speaking in fractions that are different but equal. In math, finding the simplest form, The most reduced fraction is like distilling a sentence down to its essence, clear, unmistakable. So next time you see 8/12, pause and ask, what's hiding inside this number? The answer is 2/3, the same value, just waiting to be revealed. Chapter 9. Fractions in the Real World. Fractions may seem like something from textbooks and chalkboards, but their true magic lies in everyday life. They hide in recipes, construction, music, even time, waiting to be noticed. Imagine baking a cake. A recipe calls for 3/4 cup of flour and 1/2 cup of sugar. These aren't just numbers, they're precise instructions guiding your hands. You might double the recipe or cut it in half. Each adjustment, each portion, is a dance of fractions. Or think about music. Notes are counted in beats, often divided into halves, quarters, and eighths. A whole note, a half note, a quarter note, each representing a fraction of a measure, a symphony of math hidden in harmony. In building and carpentry, measurements are often in inches and fractions of inches, 1/4 inch too short, or 3/8 inch too wide. Precision matters, and fractions are the language of getting it right. Even in time, we talk about half an hour, 3:15, or 1/3 of a day. Time flows in fractions, quietly organising our world. When you divide a bill between friends, or share a pizza among 6 people, or measure ingredients in a kitchen, you're using fractions. Not with fear, but with familiarity. They become second nature. Fractions are everywhere, not because they complicate things, but because they help divide, share, balance, and build. They're not just numbers, they're tools. And once you notice them, you'll see they've always been part of your life. Chapter 10. Mixed numbers and improper fractions. Let's turn now to a beautiful duality in math. 2 different ways to express the same thing. Sometimes the way you look at a number makes all the difference. Imagine you have a pie, and then another full pie, and then half of a third. You have 2 whole pies and a half. That's what we call a mixed number, a whole number combined with a fraction, in this case 2.5. But now imagine you want to count all the pieces if the pies are each cut into halves. 1 pie is 2 halves, so 2 pies are 4 halves. Add 1 more half and you get 5 halves. That's the improper fraction 5 halves. The mixed number 2.5 and the improper fraction 5 halves are different ways of expressing the same amount. One emphasizes the whole and the part. The other is a single fraction that stretches past one whole. Let's look at another example. 3 3/4. This is a mixed number. To convert it to an improper fraction, multiply the whole number, 3, by the denominator, 4, which gives you 12. Add the numerator, 3, and you get 15. So the improper fraction is 15/4. Why use improper fractions at all? Because in equations and algebra, they're often easier to work with. They avoid the split between whole and part. They keep things streamlined. But in conversation or storytelling, when describing food, time, or distance, we often favour the mixed number. It's more natural. I walked 2.5 miles rolls off the tongue better than I walked 5 halves of a mile. Each has its place. Mixed numbers are for moments, improper fractions are for math, and converting between the two is simple, gentle arithmetic, a quiet shift in perspective. When you look at a number, ask yourself, do I want to see the whole and the part, or just the sum of the parts? Either way, you're right. They're just 2 voices telling the same story. Chapter 11. Adding and subtracting fractions. Adding and subtracting fractions can feel like assembling a puzzle. Each piece must fit just right. And like all good puzzles, the first step is finding a common connection, a shared denominator. Imagine you're baking. One recipe calls for 2/3 cup of sugar. Another adds 1/4 cup. To know how much sugar you'll need in total, you must combine those two measurements. But before you can add 2/3 and 1/4, they need to speak the same language. That's where the least common denominator, LCD, comes in, the smallest number both denominators divide evenly into. In this case, it's 12. Convert both fractions. 2/3 becomes 8/12 and 1/4 becomes 3/12. Now, it's easy. 8/12 plus 3/12 equals 11/12. No need to reduce, no mystery, just clean math. Subtraction works the same way. Let's say you poured 5/6 of a jug of juice into glasses, and 1/2 of the jug remains. How much did you pour out? Convert. 5/6 becomes 10/12. 1/2 becomes 6/12. So you poured out 10/12 minus 6/12. 6/12 equals 4/12, which simplifies to 1/3. There's something satisfying about it, taking two fractions and reshaping them into one meaningful whole, or discovering the difference between two parts of a shared space. Sometimes you'll need to reduce your answer, trimming it to its simplest form. Other times, you might end up with a mixed number, like 5/4 becoming 1 and 1/4. It's all part of the story fractions tell. Adding and subtracting fractions is a quiet act of balance, merging pieces of a whole or gently measuring the space between them. It teaches us patience, precision, and how to find common ground. Chapter 12. Multiplying fractions. Multiplying fractions might sound intimidating at first, but it's one of the most straightforward and elegant operations in all of math. Unlike adding or subtracting, where you need to adjust and align denominators, multiplication asks for no such negotiation. It simply flows, top times top, bottom times bottom. Let's say you want to find 1/2 of 3/4. You multiply the numerators. 1 times 3 equals 3. Then the denominators. 2 times 4 equals 8. So the answer is 3/8. In everyday life, this comes in handy more often than you think. Imagine you've eaten 3/4 of a pizza and want to know how much you've eaten if you shared half of your portion with a friend. You're finding half of 3/4, which is, again, 3/8. A tangible, tasty use of math. Or imagine a recipe that says, use 2/3 of a cup of flour, but you're only making half a batch. How much flour is that? Multiply 1/2 by 2/3. Top times top. 1 times 2 equals 2. Bottom times bottom. 2 times 3 equals 6. That's 2/6, or 1/3 cup of flour. This idea of multiplying parts of parts is central to understanding how portions shrink, how spaces divide, and how scales reduce. It's used in cooking, art, construction, and it reflects a deeper understanding of proportion. What about whole numbers? Multiplying a fraction by a whole number is just as clean. Say you want to know how much is 4 times 2/5. Think of it as 4 over 1. 4 over 1 times 2/5. Top times top. 4 times 2 equals 8. Bottom times bottom. 1 times 1 equals 1/5 equals 5. So you get 8/5, or 1 3/5. It's peaceful work, this multiplication of quiet numbers. Unlike the hurried pace of long division or the juggling of subtraction, multiplying fractions is like pairing dance partners who already know the steps. There's no stress, just rhythm. Multiply across, simplify if needed, and smile at the simplicity of it all. Chapter 13. Dividing fractions. If multiplying fractions is a graceful duet, dividing fractions is a clever reversal, a small but brilliant twist that reveals math's quiet elegance. When you divide a whole number by a fraction, or a fraction by another, you're asking, how many of these parts fit into this whole? And the way to answer that is through a simple trick. Multiply by the reciprocal. Let's take a calm walk through the concept. Suppose you have 1 divided by 1/2. That seems odd at first, but think of it in a real-world way. How many half pieces fit into one whole? 2. So 1 divided by 1/2 equals 2. Mathematically, we flip the second fraction. 1/2 becomes 2/1, and multiply. 1 divided by 1/2 equals 1 times 2 divided by 1 equals 2. That's the core of dividing fractions. Keep the first, flip the second, and multiply. It's called invert and multiply. A quiet mantra for clarity. Let's do another. 2/3 divided by 4/5. Keep 2/3. Flip 4/5 to become 5/4. Multiply. 2/3 times 5/4 equals 10/12. Now simplify. 10/12 becomes 5/6. So 2/3 divided by 4/5 equals 5/6. Not bad at all. This isn't just abstract math. It has calm, practical echoes in real life. Suppose you're sewing and have 2/3 of a yard of fabric. Each decorative patch takes 4/5 of a yard. How many patches can you make? Not quite one. Just 5/6 of one to be precise. You might get close, but not a full patch. Fractional truth softly revealed. Dividing fractions reveals proportion in reverse. Instead of seeing how parts add up, we ask, how many parts are there in this amount? It helps us allocate, stretch, plan, and divide. It's also a quiet reminder that answers often lie in a shift of perspective. By flipping the fraction and multiplying, you're not breaking the rules. You're understanding them in a deeper way. So next time you divide, remember, keep, flip, and multiply. It's math's calm little secret, quiet but powerful. Chapter 14. Word Problems and Real-Life Fractions. As we drift into deeper understanding, we now step into the most human part of mathematics, the stories. Word problems are where numbers meet real life, and fractions begin to speak in full sentences. They might ask, if Sophia read 3/4 of her book on Monday and another 1/8 on Tuesday, how much has she read? We pause. We picture her curled in a chair, a book open. Then we add 3/4 plus 1/8. To do this, we need a common denominator, 8. So 3/4 becomes 6/8, and adding 1/8 gives us 7/8. She's nearly done, only a sliver left. Another might ask, a painter used 2/5 of a gallon of paint for one wall and 3/10 for another. How much was used in total? The math whispers, find the common denominator. Here, it's 10. Convert 2/5 to 4/10. Add to 3/10. The answer is 7/10. This is math in motion. It paints, it reads, it bakes, it drives. A recipe asks for 3/4 cup of flour and you're making only half the portion. Multiply. 1/2 times 3/4 equals 3/8. That's the portion you need. Or a bike trail stretches 2 2/3 miles. You've already ridden 1.5 miles. How much is left? Turn them into improper fractions. 2 2/3 is 8/3. 1 1/2 is 2/3, 3/2. To subtract, find the common denominator, 6. 8/3 becomes 16/6. 3/2 becomes 9/16 minus 9/16 equals 7/16 equals 1 1/6, 1/6 mile left. In every word problem, the math becomes textured, grounded, no longer floating in abstraction, but tucked into quiet corners of life. And each one teaches more than just operations. It teaches interpretation, estimation, logic, patience. It reminds us that numbers are not distant. They live among us. They count our steps. They guide our recipes. They split our days and tally our dreams. In every subtle, sleepy word problem, math becomes a story. One that invites you to solve, to think, and to see. Dividing fractions reveals proportion in reverse. Instead of seeing how parts add up, we ask, how many parts are there in this amount? It helps us allocate, stretch, plan, and divide. It's also a quiet reminder that answers often lie in a shift of perspective. By flipping the fraction and multiplying, you're not breaking the rules. You're understanding them in a deeper way. So next time you divide, remember, keep, flip, and multiply. It's math's calm little secret, quiet but powerful. Chapter 15. The language of estimation. Estimation is where precision softens and intuition begins. It's the gentle art of close enough, where math becomes more of a whisper than a command. In the world of fractions, estimation helps us sense size without calculating exactness. It lets us glance at 5/8 and think, that's just a little more than half, or see 7/10 and feel, that's nearly 3/4. Why does this matter? Because life often doesn't require exact answers. Not always. Sometimes we just need a sense of things. How much gas is left in the tank? Is that shelf halfway up the wall? Do we need one more bag of flour, or will what's left be enough? Let's take 11/16. Estimating helps us quickly say, that's close to 3/4. That kind of number sense guides us when we're cooking on instinct, painting without measuring tape, or solving problems in our heads. We might look at 2/5 and compare it to 1/2. Since 2.5 is exactly 1/2, we know 2/5 is a little less. Not by much. That quiet nudge is all we need. In schools, estimation shows up in mental math. On tests, it helps double-check answers. In design, it guides proportions when measuring isn't possible. And in conversation, it makes math feel more natural. About 1/3, we say, or roughly 3/4. Estimation encourages comfort with numbers. It builds fluency. And it teaches something important, that math doesn't always have to be exact to be useful. So when you see a fraction, don't rush for a calculator. Breathe, picture it, round it gently, feel what it's close to. Estimation is the math of mindfulness, a soft skill, a kind intuition, and it reminds us that even in precision's shadow, there's peace in the almost.
Chapter 17. Fractions in Nature. Step outside and you'll find fractions whispering through the world around you, not as numbers but as patterns, proportions and quiet symmetries. Look at a leaf. Its veins may divide it in half, then into quarters. A branch may split into two, then two again, forming a natural binary tree. A spider's web stretches in radiating thirds and eighths. Shells curve in spirals formed by golden ratios which are not fractions exactly, but closely related to them. Parts of wholes delicately balanced. When bees build honeycombs, the hexagons they create divide space with precise symmetry. Each hexagon is equal, part of a grid that covers the hive without overlap or waste. Mathematically, it's a marvel. Practically, it's a perfect use of fractional geometry in nature. Petals often follow fractional sequences. You might see 3 petals or 5 or 8 numbers in the Fibonacci series, which emerges when we add the last 2 numbers to make the next. Each new growth a combination of what came before. Even animal patterns reflect fractions. Think of the stripes on a zebra or the markings on a butterfly's wings. They mirror across the center, dividing the creature into halves. Then smaller portions again and again. Rainbows arch across the sky in layered bands, each taking a fractional portion of the light spectrum, a quarter of the sky, half of the hill, eighths of sunshine across the forest floor. In the ocean, waves move in rhythm, not exact fractions, but measurable crests and troughs that follow patterns. Tides rise and fall with lunar poles that divide the day into fractions of high and low. Nature rarely demands the rigidness of human-made math, but it uses parts and wholes, balance and symmetry, growth and division, all built on the quiet backbone of fractional understanding. To walk through nature is to walk through a living mathematics, a subtle geometry of trees, tides and time. You don't have to measure it, just feel it. Breathe it in, know that it's there, because even in the chirp of birds, the flicker of wings, or the spiral of a pine cone, fractions are softly keeping time. Chapter 18, Fractions in Music and Rhythm. Close your eyes and listen. Beneath every song, every beat, every melody, there's math at play, and often, at its core, is the fraction. Music divides time. A measure of music might be broken into 4 beats. A whole note lasts the full measure. A half note, 2/4. A quarter note, 1/4. Eighths, sixteenths, smaller and smaller divisions of time. Each sound you hear fits into a fraction of a moment. Each silence, too. When a drummer counts 1 and 2 and 3 and 4, they're working in eighth notes. When a jazz pianist syncopates a melody off the beat, maybe at 3/8 or 5/8 time, they're bending the rhythm with precision. In classical music, composers like Bach and Mozart use time signatures like 6/8 or 12/8 to create flowing patterns that feel like waves. Triplets, 3 notes in the space of 2, are another lovely fraction, a dance of thirds within a framework of halves. Even in modern pop music, beats and bars are built from divisions. Producers layer 1 and 16 hi-hats, or cut vocals into 1/8 bars. It's math, but felt through the body, and for those who dance, each step falls on a fraction of a beat. The waltz, in 3/4 time, pulses with a soft elegance. 1 2 3, 1 2 3, a cycle of thirds. Fractions give music its tempo, its space, its signature. Without them, the music would lose form, like a story with no punctuation. But what's most beautiful is how these fractions vanish into feeling. We don't count as we sway to a lullaby. We don't calculate as we hum a tune. Still, those fractions are always there, gently holding the rhythm, quietly keeping time. They shape not just music, but how we move through sound. And when night falls and the world slows, they remind us, even in silence, there's structure. Even in the hush, there's rhythm. Even in rest, there's math. Chapter 19, Fractions and Fairness. Fractions often appear when fairness is at stake, when something must be shared, when balance matters. Imagine you're slicing a cake at a birthday party. There are 8 guests, 1 cake. How much does each person get? You divide it, 1/8 each, 1/8 of a whole. That's fairness, drawn with frosting and a knife. Or consider splitting a bill at dinner. The check comes to $60, and there are 4 of you. That's $15 each, 1 and 4 of the total. Fairness through fraction. In classrooms, teachers use fractions to assign shared time. Each group gets 1 and 3 of the hour. In sports, the game is divided into halves, quarters, equal chances for both sides. Even voting can use fractional thinking. In some systems, a candidate must gain more than 1 and 2 of the votes to win the majority. It's a line drawn by a fraction, a definition of enough. Fairness isn't just about numbers, though. It's about perception. 2 people might split a sandwich in half, but if one half is thicker or has more cheese, the math doesn't feel right. That's where fractions meet feeling, where numbers meet judgment. Kids notice it quickly. His piece is bigger than mine. So we learn not just how to divide, but how to do so visibly, clearly, kindly. We fold the paper in front of everyone. We draw the lines. We show our work. Fractions teach fairness, because they are fairness, made measurable. And in a world where not everything can be equal, they remind us that effort matters, that precision helps, that thinking in parts, thoughtfully, deliberately, can make sharing softer, smoother, better. The next time you divide something, a chore, a cost, a cake, know that you're doing more than math. You're practicing empathy. And in those small slices of fairness, there's Chapter 20, Fractions and the Cosmos. Even the cosmos, vast, mysterious and immeasurable, holds room for fractions, not just in the calculations of astronomers, but in the very way we perceive space, time, and light. Take the phases of the moon. Each cycle from new moon to full is a fraction of its orbit. First quarter, last quarter, half the moon illuminated, half in shadow. The Earth itself tilts at a fraction 23.5 degrees. Not a full right angle, not half of one, a portion just enough to shape the season. Distances in space are described through proportions. A planet might be 1/3 the mass of another. A star might burn twice as bright as one nearby. Light years, parsecs, enormous measurements, but still divisible, still comparative. Eclipses are moments of perfect alignment, the moon covering a portion of the sun's disk, sometimes a sliver, sometimes totality, each one a dramatic expression of celestial fractions. Even starlight that reaches us has been filtered, scattered, fractioned by dust and atmosphere. What we see is a part of what was sent, a whisper from the past, softened and divided. And time, the great backdrop of space, is marked in fractions too. Days are divided into hours, minutes, seconds. Earth's rotation is a dance of division, turning slowly, predictably. Galaxies are divided into arms, solar systems into orbits, moons into tides, and though the cosmos feels infinite, we explore it bit by bit. A telescope captures only a fraction of the sky, a probe travels only a slice of the distance, yet within those fractions lie wonder, knowledge. Math brings structure to mystery, and fractions, especially, let us break down the unimaginable into knowable parts. So the next time you gaze up at the night sky, remember, even the stars shine in pieces, and in every fraction of light the universe speaks. Chapter 21: Fractions and Storytelling. Every story is made of pieces, beginning, middle and end, acts, scenes, paragraphs, moments, fractions. Think of a novel. A common structure divides it into 3 acts, one free for setup, one free for conflict, one free for resolution. Not always precise, but a rhythm readers expect. In plays, scenes may take up halves or quarters of a whole performance. In films, screenwriters often speak of the 1/4 mark, the moment the story shifts, the midpoint, 1/3, a turning point, the last eighth, the climax. These are not just moments, they are parts of a whole, slices of a journey. Even fairy tales, simple as they seem, often follow these quiet divisions. Once Upon a Time introduces the setting, the first fraction, but then presents conflict, the second, and they lived happily ever after. The close, the final piece. Writers may not always use math, but they feel the proportions, the weight of scenes, the pace of dialogue, the space between plot points. In poetry, stanzas divide evenly, lines arranged by meter, syllables counted and balanced. A haiku, 575, 3 lines, 17 syllables, fractions of a thought. And in oral storytelling, when someone leans in to tell a tale, there's a rhythm, a pause, a beat, a careful sharing of each part. Storytelling is the art of fractioning emotion, giving just enough, then a little more, then a little more, until the whole reveals itself. And when the story ends, we realize each part mattered. No piece was wasted, no fraction too small. In the telling of tales, we live by division and come together, whole. Chapter 24: Fractions and the Passage of Time. Time feels infinite, yet we live it in fractions. We break our days into hours, 1/24 of a full turn of the earth, each hour into minutes, each minute into second. We schedule meetings for half an hour. We set reminders for a quarter past. We count down the last tenth of a second in a race. In history we measure decades, 1/10 of a century, centuries, 1/10 of a millennium. Our lives, each one a fraction of a generation, a blink in the long span of time. Seasons arrive and recede in quarters. Spring, summer, fall, winter. each a turning, a fourth of the cycle, school years, fiscal calendars, solstices, all shaped by division. Even memory works in pieces. A year might seem long, but we remember it in parts. A week-long trip here, a brief conversation there, a summer evening that felt like a whole. Some cultures divide time differently. Lunar calendars, harvest cycles, prayer hours, but always there is division, a recognition that we live not all at once, but moment by moment. We say just a second, or in a bit, or give me a minute, fractions of time, exchanged like currency, and yet in those tiny slices, life unfolds, a laugh, a glance, a choice. To live with fractions of time is to live with presence, to understand that even small pieces can be meaningful, that waiting is a part of time, that rest is too. So as you drift now toward rest, know this: the night stretches before you in quiet divisions, minutes into hours, breaths into dreams, and in every fractional moment, there's space for peace. Chapter 25. Fractions in Architecture. When we look at buildings, great and small, we often see their grandeur, their color, their scale, but underneath those surfaces, architecture is built on proportion, and where there is proportion, there are fractions. From ancient temples to modern homes, buildings are divided with care. A facade might be split into thirds, a doorway placed exactly halfway between two columns, a window positioned 3/4 up a wall. The ancient Greeks used what they called the golden ratio, a kind of mathematical perfection, to guide the layout of temples and theaters. This ratio, approximately 1.6118 to 1, can be thought of as a very special kind of fraction, a relationship between parts and wholes that feels balanced to the eye. In Gothic cathedrals, pointed arches and rose windows are spaced in fractional relationships. In Japanese architecture, tatami mats determine the scale of a room. Each room's dimensions are a fraction or multiple of that one unit. Even the humble kitchen is planned with fractions. The counter might be half the length of the wall. Cabinets might be a third of the space above. Tiles divide the floor into neat, navigable parts. Architects sketch in units. They draft in scales. They calculate stress loads and beam placements with equations that involve parts of whole. And in their finished work, the result is comfort. A space that feels just right. Even if you don't know why, that's the magic of fractional harmony. A door placed slightly too high or a window too wide. Even without noticing, something would feel off. But when the proportions are right, the space rests easily around us. We feel balance, quiet, shelter. Fractions are the invisible rules of space. They shape how we walk through the world, from the tiles beneath our feet to the beams above our head. So the next time you step into a room, look again, count the parts, trace the spacing, notice the balance. You'll find fractions sturdy, silent, sheltering, holding everything in place. Chapter 26. Fractions in Photography. Every photograph is a frozen moment, a slice of life, captured in a frame, and behind that still image, fractions are quietly at work. When a photographer adjusts their camera, they often think in fractions. Shutter speed, for instance, is measured in time, 1/60 of a second, 1 for 250, even 1000. A faster shutter speed freezes motion, a bird mid-flight, water mid-splash. A slower one blurs it, catching the graceful trails of a dancer or the gentle fall of snow. Aperture 2 is a fraction, known as the f-stop. It refers to the size of the lens opening. ff2.8, ff4, ff11. The smaller the number, the larger the opening. The larger the opening, the shallower the depth of field. A portrait with a soft, blurred background, that's a low f number. A wide open lens, a landscape sharp from front to back. A higher number, a narrower window. And then there's ISO, sensitivity to light. While not a fraction itself, it works in tandem with shutter and aperture to balance exposure. It's all about ratios, all about division. Photographers also compose their shots with the rule of thirds, mentally dividing the frame into 3 equal sections, both horizontally and vertically. Placing a subject along these lines, or at their intersections, creates balance and visual interest. Even cropping uses fractional thinking. Should the image be half the size, 1/3, should the subject take up 3/4 of the frame? These choices, often intuitive, are grounded in the quiet language of parts and wholes. And light, the painter of photography, is full of subtle divisions: a beam through a curtain, a shadow across a cheek, a gradient from morning gold to twilight blue. To photograph is to choose a fraction of time, a portion of space, a part of life worth saving. So next time you see a picture you love, think about the math behind it. The choices, the moments, the ratios. Each one a fraction. Each one a little piece of forever. Chapter 27. Fractions in Movement and Dance. Dance is the poetry of motion, and like all poetry, it lives within rhythm, timing, and division. When dancers move, they don't just flow freely, they move to counts, to measures, to time signatures. Each step is a piece of a phrase, each gesture a portion of a beat. In ballet, a turn might last for 1/4, a bar. A leap might span 3/4 of a phrase. In tap, percussive footwork often uses 1/16 and 1/32 beats. Tiny slivers of time, each one critical. In hip-hop, dancers might hit 1/4, 8 accents, syncing moves to the offbeats, filling the spaces in between. Choreographers use counts to map movements. 5, 6, 7, 8 is not just a cue, it's a signal to enter the fractioned world of musical timing. Arms extend on 1, legs step back on a pause, perfectly placed on the and between 4 and 5. Fractions also shape the stage. A soloist may occupy center. 1/4, the space. A group of dancers split left and right, balancing 1/4 to each side. Spacing, symmetry and shared timing create a visual math of bodies in motion. In traditional dances across cultures, fractional steps mark heritage and history. In Irish dance, quick 1/4, 8-note rhythms define the pulse. In West African drumming and movement, polyrhythms weave multiple fractions into one tapestry, 3/4 layered over 4. Even improvisation, the most spontaneous form, is rooted in the beat, in understanding where a moment lands, in feeling when to move, and when to let silence speak. Dance is time embodied, fractions lived through limbs. To dance is to honor the part as much as the whole. A toe tap, a shoulder lift, a turn of the wrist, each one a note in the larger score. And as the music fades and the curtain falls, what lingers is this: a shared rhythm, a counted moment, a fraction of something fleeting remembered. Chapter 28. Fractions in Visual Art. Artists, like mathematicians, understand the beauty of balance, and within every painting, sketch, or sculpture, there are fractions silently guiding the art. A canvas might be divided using the rule of thirds, horizontal and vertical lines that split the image into 9 equal parts. Artists place key subjects at these intersections, creating visual tension and harmony, not in the center, but just off it, just enough to make the image feel alive. In Renaissance art, proportions were calculated with incredible precision. Leonardo da Vinci's Vitruvian Man explored human dimensions as ratios, each limb a part of the whole. The golden ratio too appears again and again, shaping everything from faces to buildings to spiral seashells. Still life paintings often balance objects across halves and quarters. A bowl here, a vase there, a space left purposefully empty, the fraction of negative space as important as the objects themselves. In abstract art, divisions take on new meaning. Grids of 1/4, 1/16, 1/64 form intricate patterns. Lines repeat, colors shift by incremental steps. What seems spontaneous is often built on strict fractional logic. Sculptors must understand volume and surface, how a third of weight overhangs, how a piece is balanced. Ceramics too require precision. Half the clay, double the spin. Fractions in motion. Even when we doodle without thinking, we space things intuitively. A sun in the corner, 1/8 of the page. A tree in the center left, a house that takes up just half the scene. Fractions allow artists to create tension, movement, calm, to guide us without words, to suggest importance. So the next time you stand before a painting or hold a pencil to paper, consider the space, the layout, the weight. You'll find the artist has already done the math, and in doing so created something that feels just right. Chapter 29. Fractions in Nature. Look closely at the world outside your window, and you'll see that nature too divides with care. Not with rulers or formulas, but with instinct, with patterns, with quiet, elegant fractions. A leaf, for example, is not just a shape. Its veins branch out in halves and quarters, sometimes forming fractals, self-repeating shapes that echo at different scales. 1/3 of the leaf might be dense with lines, another third empty and light. Pine cones spiral in segments, seashells curve with mathematical precision, shaped by the golden ratio, a living fraction etched in calcium. Petals on a flower often follow patterns of 3s, 5s, 8s, Fibonacci numbers, each one a natural division of space and growth. Tree trunks split into halves, then halves again. Roots branch into finer and finer parts, all working together. Birds build nests in circular patterns, measuring twigs by eye, yet somehow arranging them into balanced, proportional homes. Even the path of a river is fractional, the way it divides into tributaries, smaller and smaller streams, each fork a portion of flow. In the sky, moon phases divide the month. A crescent moon is a simple fraction of a full circle. Rainbows arc in fractional bands of light. Snowflakes, with their six-fold symmetry, divide beauty into crystalline math. And we too are shaped by nature's fractions. The proportions of our bodies follow natural ratios, from fingertip to wrist, elbow to shoulder, the halves and thirds of anatomy we rarely think about, but always feel. Fractions are nature's quiet logic, unseen, but everywhere. They show up not in symbols or chalkboards, but in patterns, petals, and paw prints. So the next time you walk outside, slow down, notice the divisions, the symmetry, the silent math, written in bark, bloom, and breeze. Nature has been teaching fractions far longer than we have, and in every branch, every wing, every tide, it continues. Music, especially, is a world of precise parts. A whole note, a half note, a quarter note, an eighth, a 16th. These are not just durations, they are decisions about timing, emphasis, feeling. In a lullaby, a melody might rest on a single half note, held long enough to soothe. In a lively tune, quick eighths and 16ths flit by like birdsong. Every rhythm is a pattern of proportions. Time signatures too are fractions in disguise. 4/4, 3/4, 6/8. The top number tells us how many beats per measure. The bottom, what kind of note counts as one beat. It's a system of order, of symmetry, of shared understanding. A waltz, 3/4, 3 soft steps to a bar. A march, 2/4, 1/2, 1/2. A ballad, perhaps 6/8, lilting and light, like a rocking cradle. Even silence is divided. Rests have duration, whole, half, quarter, just like notes. A pause is not empty. It's structured, a fraction of space where nothing happens and everything waits. In nature, sound travels in pulses. Raindrops tap the roof at intervals. Crickets chirp in patterned beats. Waves lap the shore in repeating crests. Each sound a slice of a longer rhythm. Even the human voice works in parts. Syllables per second, emphasis per line, the cadence of speech, the rests between words. Fractions give sound its shape and silence its meaning. So whether you're humming softly to yourself, tapping a rhythm with your fingers, or listening to the world beyond your window, know that you're hearing math in motion. Each tone, each pause, each gentle beat is a fraction of something beautiful, and in the spaces between, just as much as in the notes themselves, lies harmony. Chapter 31. Fractions in Recipes and Cooking. The kitchen is one of the most everyday places where fractions quietly rule. Every recipe, every dish, Every measured spoonful is built on the math of part. A cup of flour, a half cup of sugar, a quarter teaspoon of salt. Recipes are not simply lists. They're blueprints, ratios of flavor, proportions of texture, carefully chosen amounts, balanced, just right. Cooking is a kind of choreography. A third of the onions go in first, half of the broth added slowly, the final quarter of the spices stirred in at the end. Each step is a time division, not just what, but when and how much. In baking, fractions are even more precise. A pie crust can fall apart if it's off by a tablespoon. Chapter 35. Fractions in sports and games. Whether played on a field, a board, or a court, games are governed by numbers, and within them, fractions play a silent but decisive role. A basketball game is divided into quarters, 4 equal parts that shape the rhythm of play. A football match splits into 2 halves. In tennis, a match is divided into sets, sets into games, games into points, each moment a portion of a contest. Scoring itself is often built on division. In golf, players tally strokes per hole, a fraction of the course total. In gymnastics, routines are judged in tenths. A deduction of 0.1 or 0.3 can shift a gold to a bronze. Fractions become drama. Even in team dynamics, roles are fractional. One player may defend, another attack, a third support. Their contributions combine to form a whole, but each plays just part of the larger puzzle. Board games use dice with 6 sides, a 1 in 6 chance for each number. Cards are dealt, a quarter of the deck to each player in some games. Strategies form around likelihoods, odds, divisions of chance and skill. In racing, fractions measure time. 1/100th of a second separates first from second. Track laps divide the race. Pace is calculated by segment. Swimmers reach the wall a fraction ahead. And practice itself is structured. A workout divided into reps and sets. Drills timed into intervals. A training week portioned into focus areas. Strength, speed, recovery. Even fans think in fractions. We're halfway through the season. 3 quarters to the playoffs. That was a half-hearted attempt. Language and feeling shaped by proportion. Games give us boundaries, balance, shared rules, and within those, fractions lend fairness. They allow for close calls, for comebacks, for clear wins. So the next time you see a game in motion, remember the parts it plays, the halves, the quarters, the near misses, and know that every cheer, every whistle, every breathless second is one small piece of the play. Chapter 36. Fractions in gardening and growth. Gardens may seem wild, free and full of chance, but look closer and you'll find a quiet rhythm. Beneath the petals and soil lies a subtle system of division, a world where fractions shape how things grow. Consider the planting bed, often split into rows and sections. A square-foot garden might be divided into 4, 9, or 16 equal parts, each one holding a different crop. 1/4 for carrots, 1/3 for herbs, a half row for beans. Seeds too are measured. Plant 1 every 6 inches, space rows 12 inches apart. Cover with 1/4 inch of soil. Even water is portioned. 1/3 of a litre for seedlings, half a can for mature plants. Too much or too little throws off the balance. Sunlight is time divided. 6 hours of light, 3 hours of shade. A plant may need full sun, meaning 203 of the day's rays. Others thrive in partial, 1 fun 2 sun, 1 fun 2 shade. Seasons shift in segments. The early third of spring welcomes greens. The middle third sees tomatoes start. The final part brings flowering vines. Each fraction of the year brings a new chapter of growth. Even pruning is an act of division. Trim back 1/3 of the branches. Harvest 1 fun 2 of the herbs to encourage more. Divide and replant bulbs in quarters. Gardening books suggest ratios: 2 parts compost, 1 part soil. Fertilize with a mix: 1 fun 2 nitrogen, 1/4 phosphorus, 1/4 potassium. Balance is everything. And when it comes time to harvest, The basket fills in stages. A few tomatoes today, a handful of peas tomorrow, 1/3 of the bed by week's end. It's not just science, it's rhythm, a slow counting of days of leaves, so when you kneel in the soil or sip tea beside a window box, think of the fractions beneath the bloom, the quiet math of growth, because even the most beautiful gardens are planted one part at a time. Chapter 37. Fractions in Architecture and Structure. Architecture is where numbers meet design, where structure is born from proportions, and at the heart of so many blueprints and floor plans, you'll find the humble fraction. A house might be divided into thirds: 1/3 living space, 1/3 bedrooms, 1/3 utility and storage. A window may occupy 1/4 of a wall. A staircase might rise at a pitch based on a 7-inch rise and 11-inch run, a fraction guiding every step. Floor plans often show dimensions 12 feet by 9 feet, but inside those numbers are parts: 1/2 of a space for the sofa, 1/3 for a table, a quarter left clear for walking. Even spacing between tiles or floorboards might be just 1/16 of an inch, and if it's wrong, the balance feels off. Columns are spaced evenly, sometimes one per every 1/3 of the room's width. Beams support loads spread over halves, thirds and quarters of the ceiling span. Builders think not just in holes, but in how those holes are shared. Classical architecture used precise ratio. The golden ratio 1:16118 appears in facades and floor plans. In Gothic cathedrals, height and width were calibrated for harmony. Arches formed by exact halves and quarters of circles. Even modern skyscrapers rise in segments. Every 10th floor might include a mechanical break. Elevators are spaced to serve halves of the tower. Lights follow patterns of 1/4, 1/3 and 1/5 for both aesthetics and efficiency. On a smaller scale, even furniture is fractional. A dining table set for 4 might use 3/4 of the room's width. A reading nook tucked into 1/8 of a room. Shelves spaced with exact fractions for different sized books. When we walk through buildings, we feel these ratios often without noticing. A room that feels just right is often one built with parts in mind. So the next time you step through a doorway, look around, count the time, notice the beams, trace the lines. You're walking through a world built one fraction at a time. Chapter 38. Fractions in Clothing and Fashion. Every stitch, every seam, every fold of fabric follows a pattern, and within that pattern lies division. Fractions shape not only the garments we wear but how they fit, how they fall, and how they feel. Clothing design begins with measurement. The chest, the waist, the inseam, all broken into parts. A pattern might call for 1/2-inch seams, a 1/4-inch hem allowance, or a neckline lowered by 3/2. Precision is essential. Tailors and designers work with templates split into sections. A sleeve may take up 1/3 of a fabric panel. A bodice, 1/2. A collar adjustments shortening a hem by 1/2-inch, tapering a pant leg by 1/4 are fractional refinements. Fabric itself is sold by the yard, cut by the 1/5 or 1/4 yard. Sewing patterns use fractions to guide every snip and stitch. Fold the fabric in half, press the seam 1/4-inch to the side, pin at intervals of 1/2-inch. Even fashion's visual balance is fractional. A skirt cut to 2/3 of leg length, a belt that divides a torso at the golden ratio. Proportions flatter when they follow natural parts. In historical garments, fractions ruled form. Corsets tightened by precise halves. Kimonos wrapped with folds measured by hand lengths. Even modern tailoring speaks of thirds: top, middle, bottom to balance silhouette. Patterns on clothing reflect division too. Stripes spaced in 1/4-inch increments. Plaid woven in grids of halves and quarters. Even asymmetry is intentional. A sleeve ending at 2/3 length, a hem angled at a quarter turn. Closets are organized by fraction, whether we know it or not. Half of our wardrobe might be seasonal, a third dedicated to work, a small fifth reserved for something special. In clothing, fractions aren't rigid, they're graceful. They help fabric move, they help garments breathe. So next time you get dressed, or watch a designer at work, notice the parts that build the whole, the division that makes fashion flow, because elegance too can be measured, one thoughtful fraction at a time. Chapter 39. Fractions in painting and color mixing. Art, too, is a world of quiet mathematics. A canvas may begin as a blank hole, but the brush breaks it into parts, each stroke a fraction of expression. Painters divide space instinctively. A third for the sky, a quarter for foreground detail, a horizon line drawn halfway through the page. These aren't calculations, they're intuitions guided by balance. Even color is measured in parts. To mix green, combine equal parts blue and yellow. For a softer hue, add a third part white. A warm shade might need just one fight red. Each tone, each shadow is shaped by proportions. In watercolor, artists control dilution. 1 part pigment to 2 parts water for a soft wash. A dry brush with 3:4 paint, and 1:4. In oils, linseed oil is added in small fractions to adjust flow. The rule of thirds, a compositional guideline, divides a frame into 9 equal sections. A subject placed along 1/3 of the canvas feels more natural, more dynamic. It's a fraction that brings harmony. Artists often work in series, breaking large works into panels. A triptych divides a story across 3 parts. Sketchbooks fill page by page. A half-drawn idea here, a third finished study there. Even the act of painting happens in phases. The first layer may cover 1:2 the surface with base tones. The next, 1:4 detail. The last, the final 1 fight. A highlight, a glint of light. Color wheels show fractions too. Primary hues spaced at thirds, complementaries opposite each other. Tertiaries filling the gaps. Each shade a calculated sliver of the circle. To the viewer, a finished painting may seem whole, but to the artist it's built in pieces, 1 stroke at a time, 1 fraction after another. So next time you stand before a painting, step closer, notice the division, the layers, the balance, because behind every masterpiece lies a quiet mathematics of color, space and care. Often, it's the invisible harmony of proportion, a quiet symphony of fractions shaping space. Interior designers begin with floor plans. A living room may be divided into thirds, 1/4 for seating, 1/4 for flow, 1/4 for display. Furniture is placed with fractional precision, a sofa taking up 2/5 of a wall, a rug extending through. Across a floor, coffee tables are often set at 1/2 the height of the surrounding furniture. Shelving is mounted in thirds, spacing objects in visually pleasing division. Curtains fall to 1/2 inch above the floor, just enough for a clean line. In dining rooms, the table might take up 1/4 of the room's length, leaving space to walk and move. Light fixtures hang at 2/3 of the ceiling height. Cushions are arranged in sets of halves and thirds. Minimalist spaces embrace negative space, using 1/4 or even 1/5 of the room for actual furniture, allowing light and emptiness to breathe. Maximalist rooms balance busy areas with 1/3 open floor. Even accessories reflect division. A mirror centered on a wall, 1/4 above and 1/2 below the eyeline. A trio of vases arranged in descending 1/4 and 1/4 sizes. Throw blankets folded into quarters. In bedrooms, comfort is crafted from parts. A bed may fill 2/3 of the room width. Nightstands sized to 1/4 the bed's length. Lamps reaching 1/4 of the way up the wall. These choices feel intuitive, but they are shaped by quiet math, a sense that everything fits, that nothing is too much, that parts make the whole. So as you sit in your favorite chair, notice the layout, the space, the way your surroundings support you. Fractions, again at work, designing peace, 1 part at a time. Chapter 41, Fractions in Astronomy and Space. In the vast silence of the cosmos, even the grandest distances and the brightest stars are measured in part. Astronomy, the study of all that lies beyond Earth, is filled with fractions that help us grasp the ungraspable. The moon, for instance, passes through its phases in eighths. New moon, waxing crescent, first quarter. Each step is a fraction of its orbit around Earth. We speak of a half moon, yet it reflects only 1/4 of the sun's light. Time too is divided. A sidereal day, the time it takes Earth to rotate once relative to the stars, is a fraction shorter than our solar day. Our calendar divides the year into months, each a part of Earth's journey around the sun. Distances in space are incomprehensibly large, so scientists speak in light years. The distance light travels in 1 year, and pass even that into smaller pieces. A star may be 4.2 light years away. A planet, just 1/10, Fractions make the unfathomable manageable. Telescopes slice the sky into degrees, minutes and seconds. Constellations occupy parts of the celestial sphere. Observatories divide their viewing schedules into slots. 1 Fury of a night for this nebula, 1 Fan 6 for that comet. Space missions rely on fractional calculations, trajectories adjusted by thousandths of a degree, orbits plotted with precision down to the tenth of a second, fuel reserves measured in quarter percentage. Astronauts aboard the International Space Station live in fractional gravity, roughly 9/10 the experience of free fall. Their lives are timed in modules, tasks divided into 1 4-hour increment. Even their sleep cycles reflect Earth's division into day and night, though they see 16 sunrises per Earth day, and when we gaze up, whether at a crescent moon or a sliver of Venus, we're witnessing fractions in motion. A planet halfway to alignment, a satellite 1/3 across the sky. The night sky, though endless, is not chaotic. It is measured, divided, understood through math and mystery. So next time you step outside and look up, think of the parts you're seeing, the celestial divisions, and know that even infinity has its fraction. Chapter 42, Fractions in Literature and Storytelling. Every story is a collection of moments, a journey split into parts, each one shaping the whole. Whether spoken by a firelight whisper, or printed on yellowed paper, stories unfold through fractions. Novels have chapters have scenes have beats, each one a portion of the narrative arc. A book might rise slowly in the first third, reach its climax at the 2/3 mark, and resolve in the final quarter. Writers structure their plots in fractions. The 3-act structure divides stories into beginning, middle and end, roughly 1/3 each. Some stories shift in quarters: exposition, rising action, climax, denouement. Others are paced in halves: setup, payoff. Page counts matter too. A short story might run 10 pages, with tension rising at 1/3, turning at 2-3, and closing in the final few paragraphs. In an epic novel, whole lifetimes are fractioned across volumes. Even within a sentence, rhythm can be felt in parts. Clauses balance each other like halves. Dialogue breaks the text in thirds. Paragraphs space the story's breath. Poetry, perhaps the purest literary form, often relies on form and proportion. Sonnets in 14 lines, haiku in 5-7-5, rhymes in couplets or quatrains. These aren't limits, they are elegant frameworks. Readers too take in stories in pieces. A chapter before bed, a third of a novel on a rainy Sunday, a bookmark halfway through. We digest narrative in fractions, letting time soften each part. Audiobooks are measured in hours and minutes, but we remember them in scenes, in that one chapter, that one line, that one moment. Maybe just a sentence, 1/100th of the book, that stays forever. Stories speak to the heart, but they are guided by invisible math, balance, timing, segments of feeling. Each part builds tension, emotion, meaning. So as you read, or write or dream, remember, every tale is told in parts, and every part, no matter how small, carries the weight of the whole. Chapter 43, Fractions in Weather and Forecasting. Weather seems wild, unpredictable, a swirl of clouds and winds, but behind it all lies math, patterns, and parts. Fractions help us understand the sky. Forecasts talk in chances: a 40% chance of rain, partly cloudy skies. These are divisions, portions of possibilities. A storm may cover 1/3 of a region. Sunshine may break through for half the day. Meteorologists study the atmosphere in layers. The troposphere, where weather happens, is only a fraction of the full atmosphere, about 1/10 of its total height. Within it, air masses shift in thirds: warm fronts, cold fronts, occluded fronts. Cloud cover is measured in eighths. Scattered clouds means 3/8 of the sky is blocked. Overcast is 8. A clear day, 0/8. These fractions help pilots, farmers and planners see what's coming. Rainfall is measured in fractions of inches or millimeters. A drizzle might bring 1/10 of an inch. A downpour, several. Snowfall, 2. A 1/4 inch dusting, or a storm dropping a foot in divided hours. Wind speeds change by parts. A gust might double the steady wind. Storm warnings are issued when speeds cross thresholds. 3 to 4 of hurricane strength. 102 visibility in fog. 103 chance of hail. Even seasons are divided. Spring into early, middle, late thirds. Weather patterns follow cycles El Niño and La Niña, each affecting parts of the globe in waves. When we look at a weather app, we see segments, the next 24 hours in hourly blocks, a 5-day forecast in fifth, a radar scan that shows storm cells in quarters across the map. But beyond the numbers we feel it too, that moment, a single sliver of a day when clouds part, when rain taps gently for 1/10 of an hour, when the wind quiets for a fleeting half minute. So next time you hear the forecast or feel the breeze, know the sky is speaking in parts, and weather, for all its chaos, is built on the balance of fractions. Chapter 44. Fractions in time and memory. Time is often described in seconds, minutes, hours, but how we experience it, how we remember it, is rarely whole. It comes in flashes, in fragments, in fractions. A moment of laughter in a long afternoon, a pause in conversation that felt like forever but was only 3 seconds, a glance, a sigh, a heartbeat, each just a sliver of time, but sometimes enough to shape a memory. We divide our lives in portions: childhood, school years, early adulthood, a job that lasted 104 of a decade, a vacation that filled 152 of a year, a relationship that began in spring and ended in the final third of autumn. Even a single day feels fractional. We say the morning flew by, or I wasted half the afternoon. We measure productivity in quarters, rest in third, and memory, that soft imprecise archive, keeps only parts. Photographs are frozen fractions. A 1/500th second exposure holds a laugh, a leap, a falling leaf. Journals capture a thought that passed in 1/10 of a minute. A voicemail just 1/2 of a conversation, maybe all that remain. Time as we live it is not evenly distributed. We recall 1/3 of an event, clearly the rest blurred. We treasure fragments, a song's chorus, a line from a book, the way sunlight hit the floor for just a minute. Historians assemble centuries from pieces. Archaeologists uncover 1/100th of a structure, and imagine the whole. Personal timelines are much the same, snapshots stitched into something that feels continuous. And sleep too is split, REM and non-REM, cycles in 90-minute segments, a nap that restores a third of our energy, a dream that fills 160 of the night, but lingers like it lasted hours. So when you think of your past or plan your day, or drift off into dreams, know that time does not always come in full hours. It comes in parts, in passing, in precious, quiet fractions. Chapter 45. Fractions in travel and distance. When we journey, whether by foot, car, plane or imagination, we often think in wholes, a full trip, a completed voyage. But the road is made of fractions. The journey happens in parts. A map may show 300, but we break it down. 1/3 before lunch, another third by sunset, the final part by nightfall. We think in segments. We're a quarter of the way there, just one more third to go. Highways are measured in miles, kilometers and signs. Each marker is a fraction of the route. A gas tank may last 1/2 the trip. A scenic detour might add 1/5 to the total time. Airline flights are divided by time zones. A 5-hour flight may be 3 hours west, 1 hour south, and an hour delay. Travelers eat at odd fractions of the day. 1/4 of dinner before boarding, 1/3 of breakfast in flight. Train journeys split their schedules. 1/2-hour layovers, 1/6 of the route between stations. Ticket prices sometimes scale by distance. A fare for 1/2 the journey, 3/4 for a premium seat. Even on foot we divide. We've walked 3, 4, 5 of the trail. The summit is just one more quarter turn. Our energy, our time, our motivation, all managed in parts. Vacations are remembered this way. The first day we explored, the second half was restful. That one sunset, 1/365 of a year, stays with me. Unpacking too is fractional. Half the suitcase for clothes, a quarter for toiletries, 1/8 for books and souvenirs, each item claiming a piece of the whole. Travel is motion, and motion is measured.
in miles, in time, in memory. So whether you're watching clouds from a plane, or landmarks pass from a train window, know this: every great journey, even one across the world, happens a little at a time, one quiet fraction after another. Chapter 46. Fractions in Communication and Language. When we speak, we often think we are expressing whole ideas, complete sentences, entire feelings, but communication, like so much else, is made of parts, of pauses, of pieces, of fractions. In conversation we share the floor. One person speaks while another listens. The time is divided. A talkative friend might speak for 3/4 of a lunch break. A thoughtful pause may last 1/5 of a second, just long enough to shift the meaning. In writing, punctuation creates rhythm. A semicolon divides two thoughts. A dash offers contrast. Paragraphs break information into chunks. Even a list like this one is made in parts. Email threads stretch across days, each reply a piece of a full exchange. A misunderstanding might be rooted in 1/3 of a sentence skipped. A joke can land or falter based on a 1/2-second delay. In public speaking, timing is measured. A speaker plans 1/3 of their time for setup, 1/3 for evidence, and 1/3 for conclusion. A great speech pauses every so often, 2 seconds here, 3 there, to let meaning settle. Language learners think in bits: 1 verb, half a sentence, 1/3 of a conversation. Fluency arrives not all at once, but in gathered fragments. Poetry and song live in meter: 3/4 time, 6/8 rhythm. A stanza might be 1/4 of the whole poem. Repetition divides and deepens meaning. Even silence speaks. A pause between words may be 1/10 of a second, but it can change everything. In tense moments we say, "You could cut the silence." What we mean is that silence, that fraction of a moment, was full. Social media compresses thought. A tweet might be 1/3 of a larger point. A meme captures 1/10 of a feeling. We scroll through snapshots, fragments stitched into the sense of a shared world. So as you read this sentence, or speak with a friend, or scroll through a feed, remember, language is not one great leap of clarity. It's the sum of every word, every breath. A conversation made of quiet, thoughtful fractions. Chapter 47. Fractions in Cooking and Recipes. Step into any kitchen and you'll find a world ruled by ratios. Recipes are instructions, but more than that, they are blueprints of parts, measurements, halves, thirds, quarters. Cooking is chemistry in fractions. A cake might need 1/2 cups of flour, 3/4 cup of sugar, 1/2 teaspoon of salt. Every ingredient is a part of the whole, adjusted, substituted, reduced. A good cook learns to eyeball a third, to trust a pinch, to recognize 1/4 cup by weight. Baking especially is precision. Reduce a liquid by 1/3, too much, and the dough won't rise. Add 1/2 teaspoon too little yeast, and a loaf flattens. Pastry chefs balance fat to flour at exact ratios, 3:1 or sometimes 2:1. Change the parts, and the result changes. Even timing is split. Simmer for 15 minutes, let rest for 1/4 of an hour. Flip after 3/4 of the cooking time. A roast may need 1/2 hour per pound. Divide and multiply. Portions are served in fractions too. Half a plate of greens, 1/3 of a pie, 1/8 of a pizza. We measure not just to create, but to share. Cuisine across the world embrace this logic. A Japanese dipping sauce might be 1/1 soy, mirin dashi. A French vinaigrette is 3 parts oil, 1 part vinegar. Indian spice blends may call for 1/2 turmeric, 1/4 cumin, a pinch of chili, a whisper of heat. Even instinctual cooking follows rhythm. Stirring for 1/2 a minute, letting a broth reduce by 1/3, pouring batter into a pan, filled 3/4 full. It's less about following and more about feeling, sensing when the parts are right. And afterward, leftovers become new meals. 1/3 of the stew added to rice, half a sauce saved for tomorrow, 1/4 of the soup frozen for later. Cooking is nourishment, yes, but it's also numbers. It's life, measured, and made with fractions. Chapter 48. Fractions in Engineering and Construction. Every bridge, building and blueprint is born in numbers. Engineering isn't just about strength or scale. It's about precision, and at its heart lies division. Fractions turn imagination into infrastructure. Before a beam is placed, or a brick is laid, a plan is drawn. That plan is divided into parts. 104-inch wall thickness, 3/4 spacing between fixtures, 116-inch allowances for expansion. Even the grid of graph paper can be read in halves, quarters. Engineers measure load-bearing limits by parts. A beam may support 2/3 of a load, with 1/3 distributed across secondary supports. A safety margin of 1/10 is added to ensure reliability. Precision saves lives. In construction, cuts are measured in fractions of inches. A tile laid too long by 1/8 can misalign a whole wall. Angles are divided. 1/2 of 90 degrees for perfect joins. Leveling tools account for 1/100th differences to prevent tilt or sag. Concrete is mixed in ratios. 1 part cement, 2 parts sand, 3 parts gravel. Add 1/2 gallon of water per batch. No more. The balance must be exact or the strength fails. Buildings rise in segments, foundations poured in thirds, floors installed 1/2 at a time, drying times measured in hours. Paint dries in 1/4 day, plaster in 3. Architects think in scale. A model may be 100 the real size. A staircase may rise 7 inches per step. A vertical fraction designed for comfort. Railings spaced at 1/2 meter intervals. Windows centered at 1/3 wall width. Bridges, towers, tunnels, all shaped by division. A span divided into equal supports. Tension cables calibrated to carry 1/6 of a load each. Expansion joints spaced every 1/5 of a mile. And when it's complete, a house, a school, a library, it feels solid, seamless, but behind every wall and wire is a story of careful math. Fractions build the world. Quietly, precisely, one measured part at a time.
Chapter 49, Fractions in Gardening. Nature. Nature doesn't deal in whole numbers. From the spiral of a sunflower to the way a tree branches, the natural world thrives in fractions. Gardening, too, is an act of quiet division, one that mirrors the soft rhythm of math. Seeds are planted in rows, spaced 1/4 inch deep, 3 inches apart. A garden bed may be divided into sections 1/4 for vegetables, 1/4 for herbs. Time is measured in growth cycles, 1/3 of a season to sprout, 2/3 to bloom. Watering schedules follow portions, 1 cup per plant, 1/2 a can for seedlings. A garden may need 1/4 inch of water per week, delivered slowly 1/4 inch at a time. Even sunlight is split. Full sun means 6 or more hours. Partial shade about 1/3 of the day. A plant may thrive with just 1/4 day exposure depending on the species. Compost mixes follow fractions: 1 part green waste, 2 parts brown, 1/4/8 water. The soil enriched in these ratios becomes a silent equation, and when we harvest, 1/3 of the basil, 1/2 of the tomatoes, 1 strawberry ripened after 1/4 of the summer. Gardening teaches patience. It teaches parts, each bloom, each root, each raindrop, a step in a fractioned rhythm of growth. Chapter 50, Fractions in Music and Sound. Music is time divided into rhythm, a symphony of parts that becomes emotion. Fractions are at the heart of every beat, every pause, every chord. The 4/4 time signature means 4 beats per measure, each beat 1/4 of the whole. A half note rings out for 2 beats. A 16th note for just 1/4 of 1, it's math in motion. Musicians think in segments. The chorus may be 1/3 of the song, the bridge 1/4 to 6. Practice routines are split into intervals, 15 minutes on scales, 1/4 hour on technique, 1/4 hour on composition. Volume is scaled too. The violins whisper at 1/4 volume. A crescendo oozing steadily over 3/4 of a phrase. Echoes fading by halves until silence. Digital music editing shows sound waves sliced in parts, samples, loops and tracks divided by seconds and bars. A producer might loop 1/4/8 of a section to build a song's bass. Harmony itself lives in ratio. The pure math of intervals. An octave is a 2/1 frequency ratio. A perfect fifth is 3/2. Our ears interpret these parts as so. When you hum a tune or hear a symphony swell, know this, it's all fractions. Sound, sculpted in parts. Music, counted in silence and motion. Conclusion? The quiet power of fractions. Fractions are everywhere. Not in textbooks, but in teacups. Not just in school, but in starlight, footsteps and stories. They whisper balance, offer structure, create space. They shape our lives in subtle ways, in portions of time, in pieces of memory, in slices of experience. So the next time you measure, plan, build, listen, or simply breathe, remember, wholeness is made of parts, and every part matters. Good night. Rest well, and let the quiet comfort of fractions ease you into sleep.